Hi, this is Chris, and we are taking a look here in section 4 of SAT Practice Test 5 at questions 16 through 18. So all three questions pertain to this information seen here. And they give us a table, and then in the text it says one method of calculating the appropriate age in years of a tree of a particular species is to multiply the diameter of the tree in inches by a constant called growth factor for that species. The table above gives the growth factors for 8 species of trees. So in the text, they tell us an equation. They're basically saying that your age is equal to your diameter times your growth factor. And you can use whatever variables you'd like for that, but I think A, D, and G at least all represent what the different variables are in the equation. And then here, the only other thing I would really highlight is that it says in inches. So in case you get to a question where maybe they give it to you in feet or yards or some other unit of measurement, you do have to do that conversion to inches for our calculations. All right, let's take a look. So for question 16, according to the information in the table, what is the approximate age of an American elm tree with a diameter of 12 inches? So they're asking for age. They give us a diameter of 12. And we would have to find the growth factor for American elm. So for this one, we look it up in the table. We see American elm has a growth factor of 4. We plug that in. 12 times 4 gives us an age of 48. So here, we don't have to do any unit conversions. They give it to us in inches for that diameter, and the growth factor is directly from the table. So this one is a little bit of a plug and chug as long as we can get this part down. Coming up with that equation from the text given is key there. Now let's take a look at 17. And we'll have to do a little scrolling back and forth because this is still pertaining to that same table of information. And here we see a scatter plot, and it says the scatter plot above gives the tree diameter plotted against age for 26 trees of a single species. The growth factor of this species is closest to that of which of the following species of tree. So when you have a scatter plot, rather than use an individual data point, you want to try to create a line of best fit. And this does not have to be exact, but you're basically going to draw a line through the data that represents the trend in the data. And you can pick a few points along that line to confirm. So here, for example, to solve for growth factor, because we are given in the table diameter in inches, so again, we don't have to do a conversion, and we're also given age, which means that when we plug in our same old formula here, A equals diameter times growth factor, we're trying to solve for growth factor, and once we have a good idea of what that growth factor is, we can look it up in the table to see which tree species that matches. So here, for age, let's just try a few points, and I'm going to zoom in here a little bit, but let's try, for example, maybe an early point on our line of best fit, maybe somewhere midway through, maybe, like one point kind of towards the end, something like that. Just to make sure that we're not getting wildly different values for that growth factor with those different points. So here at this first point, it looks like you've got an age of 70 for a diameter of about 10. So let's see what that calculation would look like for growth factor. If you did 70 for your age equals your diameter of 10 times your growth factor and divide, you would get 7 right on the nose for your growth factor. And again, you could use that and just take the 1 point and hope that we didn't get something that was non-representative or make any mistakes. But if you want to just double down and be extra sure, let's take a look. It looks here like when our when our tree diameter is 14, that our age is about 100. And so if we just apply that same equation again, let's just see here. If we have 100 for our age and 14 for our diameter, let's see what that growth factor comes out to if we divide those. And here this would be pretty close to 7 as well. This comes out to 7.14 and change for that. And so we're probably confident enough there. If you wanted to pick one more, you could. You could say that maybe at a diameter of 16, it looks sort of like our, age is going to be maybe 120 or maybe slightly less, And so, again, you could plug it into that same equation if you want to be doubly sure, or triply sure in this case, but it looks like we're looking for a growth factor right around 7, and this is one thing that the SAT will be very friendly about. If they make you eyeball something from a graph or a table where they don't give you an exacting equation or exact values, then that means that they're not going to have a bunch of answer choices that are all close. So if we look at this table here for growth factor, the shagbark hickory is the only one even remotely close to 7. So they're usually very reasonable and very nice about that. It would be really mean if they asked us to eyeball these values and didn't give us exact values to use, and then if they had growth factors of 7.3, 7.5, 7.6, 7.4, and a bunch of growth factors that are right around 7.5, it'd be almost impossible, if not impossible, to determine. So here, we know confidently that it's got to be the shagbark hickory because that's the only one that's even close in terms of the growth factor to what we calculated based on our line of best fit. And now lastly for this set, we look at question 18. And 18 I think is the trickiest here. I actually think this is quite a difficult question for only being 18 in the section. We know that this section goes easy to hard, but this one is a little extra tough. So let's see what we have to do. If a white birch tree and a pin oak tree each now have a diameter of 1 foot, which of the following will be closest to the difference in inches of their diameters 10 years from now? So we still have just this same equation that age is equal to our diameter times our growth factor. That part's not going to change. And in this case, let's take a look. We have our white birch and our pin oak. Just so we don't have to scroll back and forth too much, I'm going to just write down the growth factors for each of those. So here, if we look at our table, white birch, that's right here, has a growth factor of 5, and pin oak down in here has a growth factor of 3. So white birch 5, pin oak 3. Let's jot that down so that we don't have to scroll back up and down, up and down, up and down. So white birch 5, pin oak 3 for the growth factor. Okay, so we're going to use our same equation that we've been using for this whole question set here related to this information, but if you notice, they give the diameter in feet. And at the beginning, we said that the diameter's got to be in inches, and sure enough, there is in fact a question where we have to do a conversion. So if it has a diameter of 1 foot, let's see what that would mean for age. So again, we'll split it up. We'll do the white birch calculations over here, and we'll do our pin oak calculations over here. So for white birch, we have age equals diameter. 1 foot is 12 inches. So we have to convert to inches. Make sure you put 12. If you put 1, calculations will be a little off. And our growth factor for white birch is 5. So that means our age right now is 60. And then for the pin oak, right now also has a diameter of 1 foot, which is 12 inches. So 12 inches times its growth factor of 3, which means its age would be 36. And that's right now. And then they want 10 years from now. So what's going to change across those 10 years? Well, the age is going to change. And then what are they asking for? They want the difference in their diameters. So we're trying to solve for the diameters here. And we're going to use our existing calculation for age. 10 years from now, that age is going to be 70. So when we go to do our equation, we're going to write it as 70, right, after this progression of time, is equal to, our diameter is now going to be the unknown, and our growth factor is going to stay the same. Our growth factor would be 5. So that would be our equation for the white birch and for the pin oak. Our age, again, same progression, it's 10 years time, so our age is going to be 46. So when we go to write out our equation in terms of age equals diameter times growth factor, we're going to go 46 equals unknown diameter times our growth factor of 3. And let's solve for each of these. So you divide both sides by 5. For the white birch, that's going to be a diameter of 14 inches. You divide both sides by 3. For the pin oak, that's going to be a diameter of 15 1/3, or 15.3. repeating inches. And the difference in those, when you subtract those, 15.3 minus 14 is going to give us, we would actually have 1.3 repeating as our exact answer, but they say closest to in the question, so it's closest to the difference, and that's going to be an answer choice of 1.3. And this approach is very common. So SAT-wise, when they give you this set of information where they talk you through an equation, sometimes they'll even give you the equation, but for some of the more challenging questions, you're very commonly going to have to apply the equation twice, just like we did here. We did it once to find a starting value, and then with some sort of change or new value, we had to do that same equation a second time. And that's what we had to do here for each of these tree species to find our current diameters 10 years after the fact and the difference in those diameters. Stay tuned and we'll jump into the rest of this.